Imagine you have a home robot, not a little disc that bumps into furniture, but a proper robot with an arm. You want it to clean up the breakfast table. You say, "Robot, please clear the table." But instead of doing it, it just waits. You try again. Pick up the blue bowl. It works. Move the blue bowl to the sink. It works. Now pick up the spoon. You realize you're going to be here all day, giving it one tiny instruction at a time.
It's a classic problem. We want to talk to robots like we talk to people, but even with the incredible advances in artificial intelligence, it's not that simple. The AI might misunderstand, or it might not know how to break down a big task into smaller steps. And worse, you have to teach it how to clear the table from scratch every single morning.
But what if the robot could learn? What if, after you walked it through clearing the table once, it started to understand the general idea? What if it could create its own shortcuts for common tasks? Well, that's exactly what a new paper from researchers at Arizona State University explores.
Welcome to Daily Papers, where we break down the latest research into bite-sized pieces. Today, we're looking at a paper called SkillComposer, Learning Reusable Skills for Natural Language Robot Programming by John Woods and Hasti Seifi.
The core idea here is to build a system that doesn't just follow a single command, but learns from every successful interaction to get smarter and more efficient over time. To do this, SkillComposer has a two-part secret sauce. The first part is something they call a generate test loop.
That sounds technical, but the idea is actually very intuitive. It's like having a buddy system for the AI. Let's say you give the robot a command, like put the apple in the bowl. The first AI, which we can call the coder, writes the code to make the robot move.
But before the robot arm even twitches, a second AI, the evaluator, steps in. The evaluator is like a skeptical friend looking over the coder's shoulder. It checks the code and asks, does this program actually do what the human asked for?
And if the coder AI made a mistake, maybe its code would drop the apple on the floor instead of in the bowl, the evaluator sends it back with feedback. It essentially says, nope, that's wrong, try again. This back and forth can happen a few times until the evaluator is confident the code is correct. Only then does the robot actually execute the command.
This makes the whole system much more reliable. Instead of just hoping the AI gets it right on the first try, you have a built-in proofreader that catches errors before they happen. But that's only half the story. The really cool part is what happens after the robot successfully completes a task.
This is the second part of the secret sauce, online macro learning. It's a fancy term for learning on the job. Every time the robot successfully completes a task, SkillComposer saves the program it used. It keeps a sort of digital scrapbook of all its successes.
Then an algorithm looks through this scrapbook for common patterns. It might notice that you often ask it to do a sequence of 3 things: grasp an object, move it to a specific location, and then release the object.
Exactly. After seeing this pattern enough times, the system says, aha, this pick up and move routine is something the user asks for a lot. Instead of writing out those 3 lines of code every single time, I'm going to bundle them together into a new skill. This new compressed skill is called a macro.
So the system is essentially composing a new skill from smaller pieces, which is why it's called SkillComposer. It then automatically gives this new skill a name and a description. The next time you ask it to move something, the coder AI doesn't have to reinvent the wheel. It can just use its new custom-made move and place skill. The system builds its own library of shortcuts tailored specifically to the kinds of tasks you ask it to do.
So does it actually work in practice? The researchers ran a study where they had 12 people who were not programmers or robotics experts use the system. They were asked to do tasks in a simulation, like preparing a meal or feeding a care recipient.
They compared the full SkillComposer system against a basic system that could only take one command at a time and didn't learn. And the results were pretty dramatic. With the basic system, people had to break down their requests into tiny, simple steps. One participant said it felt like they had to kind of program a little bit. They had to think like a computer.
But with SkillComposer, they could give much higher-level, natural commands. They could say things like swap the positions of the knife and the spoon, and the system would figure it out. It used its self-correcting loop to generate a reliable plan, and it might even use a skill it had learned from a previous task.
Users reported that SkillComposer felt like it understands me, whereas the basic system felt more like a robot. They were able to complete complex tasks with significantly fewer commands and in less time.
And what's really fascinating is you can see the learning happen. The paper includes graphs showing that as a user gives the system more commands, the number of custom macros or skills goes up. And as the number of skills goes up, the system starts using them more and more, creating shorter, more elegant programs.
This really feels like a step towards technology that adapts to us instead of us having to adapt to it. This isn't just about a robot that follows orders, it's about a robot that learns your habits and intentions.
Imagine a caregiver robot in a hospital. Instead of a nurse having to program in a dozen steps to get it to deliver a glass of water, they could just say, "Please take this glass of water to the patient in bed 3. The robot would learn that task and then learn other related tasks, gradually building a set of skills perfectly tailored to that hospital's wing's specific needs.
It's a system that doesn't just execute commands, but retains knowledge and grows with experience. By combining a clever generate test loop for reliability and an online learning module for efficiency, SkillComposer shows a promising path forward for making our interactions with robots feel less like programming and more like a conversation.